Hey everyone, and welcome. Today, we're going to get into something that really challenges the very foundation of AI research, and maybe even how we think about life itself. We're going to explore a really powerful new way of thinking about intelligence that could, honestly, change the entire game.
All right, here's how we're going to break it down. First, we'll look at the standard textbook definition of intelligence, the one that drives pretty much all AI today. Then we're going to start poking some serious holes in that definition. From there, we'll jump into a totally new way of looking at it, this idea of open-ended intelligence. We'll get into the nuts and bolts of what's called the process of becoming, and finally, we'll see how this all reframes intelligence as something much bigger, an act of coordination.
So, let's start with what we all kind of know. When we talk about artificial general intelligence, or AGI, what are we really talking about? Well, it pretty much all boils down to one deceptively simple idea: the goal-oriented agent. This right here is the gold standard. You've probably heard some version of this before. It's got three main parts, right? You've got an agent, like a robot or a piece of software. It's got goals, things it's trying to do, and it operates in various environments. The whole point of intelligence, in this view, is just getting better at achieving those goals. Seems straightforward enough.
And this is what that looks like in practice. It's a simple feedback loop. The world, the environment, gives the agent some information, and maybe a reward, like points in a game. The agent then does something, an action, to try and get more of that reward. This is the bedrock for everything from the AI that beats you at chess to the software in a self-driving car. It works, it's practical. But here's the thing, is that really the whole story?
Because this is where we start to see the cracks. It turns out that this simple, almost common sense definition is built on some pretty big assumptions. And these assumptions might just be the very things holding us back from creating truly general intelligence.
Asking this question is where it gets really interesting. If intelligence is all about achieving goals that are handed to you, what are we missing? What happens before a goal is even a thing?
Okay, flaw number one. The model just assumes that the agent and its world are two separate things. But think about it. Where did the agent even come from? How does a living cell, for example, become a distinct agent instead of just being part of the chemical soup around it? The definition totally skips over this whole messy, beautiful process of self-organization.
And the second flaw is just as big a deal. The standard model treats the environment like a static video game level that's already been designed. The agent's job is just to figure it out. But in the real world, intelligent beings don't just respond to their environment, they actively change it. And what happens when that environment is full of other agents who are also changing the rules as they go? This model just can't handle that level of dynamic chaos.
Now this one might be the deepest problem of all. The model always starts with a goal. Win the game, maximize profit. But isn't the really intelligent part figuring out what a good goal even is in the first place? Isn't formulating a problem a huge part of intelligence? By starting with the goal, we're basically jumping in at the very last step of the process. This quote from the source material absolutely nails it. General intelligence isn't about solving the puzzle. It's about realizing there's a puzzle to be solved in the first place. We've been so focused on the problem solvers that we've completely ignored the creative, messy, and deeply intelligent process of problem finding. And that's a huge leap. So, if the old model is starting to look shaky, what's the alternative? Well, this is where we get to the really cool part. The idea is to make a radical shift, to stop thinking about intelligence as a thing you have and start seeing it as a process you're in. Welcome to the idea of open-ended intelligence.
This slide really just boils it all down. We need to change the question we're asking. We've been stuck on what does it mean to be intelligent as if it's a fixed property. The new, more powerful question is, what is the process of becoming intelligent? How does intelligence actually emerge and grow over time?
And here's the new definition that comes out of that question. Forget achieving goals. Open-ended intelligence is the ongoing process of making sense of things. It's the creative act of carving out a world, of creating objects, seeing new relationships, drawing new lines where there were none before. It's not about being a player in the game, it's about being a world builder.
Okay, I know what you're thinking. Bringing forth a world sounds pretty cosmic, a little abstract. So how does this actually work? Let's break down the mechanics of this process of becoming into a few key ideas.
The central concept here is called individuation. So instead of starting with predefined agents, we look at how individuals, any kind of individual, emerge. Think about it like this. You and a friend are having a debate. You start with two separate viewpoints. But through that conversation, a totally new idea might emerge, one that neither of you had before. That new understanding is a new individual that was just born from your interaction. That's individuation. So what drives this process? It's something called transduction. You can think of it like a chain reaction. You have a structure, let's call it S1. That structure allows for a certain kind of action, O1. But that action creates a new structure, S2, which in turn allows for a totally new kind of action, O2, and on it goes. Imagine a computer program that not only processes data but constantly rewrites its own code based on that data. That's the vibe.
And what you get from this process is something called an assemblage. My favorite way to think about this is a band. You have a drummer, a guitarist, a singer. They're all individuals with their own skills, but when they come together, they create a new entity, the band, with a unique sound and capacities that none of them had alone. They're still themselves, but they formed a new, higher-level individual.
So you put all this together, individuation, transduction, assemblages, and what's the big takeaway? It means we're not dealing with fixed agents anymore. We're dealing with fluid identities. Individuals in this view are constantly in flux. They're assemblages that gain and lose parts, form new connections, and develop new abilities. Your identity isn't a fixed thing. It's a constant process of becoming.
Okay, let's take a breath. We've talked about some big, maybe unfamiliar ideas. So why does any of this actually matter? How does shifting from goal-seeking agents to these fluid, emerging assemblages help us understand intelligence? Because it all leads to this. This is the crucial point. Intelligence isn't problem-solving, it's coordination. It's the fundamental process of resolving conflict and disparity, of taking a bunch of separate, distributed parts and getting them to work together to form a functional whole that can do things none of the parts could do alone.
And what's so powerful about looking at it this way is how much it explains. It's scalable. The same process of coordination can describe how neurons form a thinking brain and how people form a functioning society. It puts creativity right back at the center of intelligence. It's about generating new things, not just optimizing old ones. And it's universal. You can apply this idea to biological evolution, to how a child learns to think, or even how a new social movement organizes itself.
So ultimately, this is the big shift in focus for anyone thinking about AI. Maybe our job isn't to meticulously engineer a perfect problem solver. Maybe it's to understand how to create the right conditions, the right playgrounds, the right ecosystems, where this kind of creative coordination can happen and intelligence can emerge all on its own. It's a move from being an architect to being a gardener.
And that leaves us with this final, really thought-provoking question from the paper. If this is what true intelligence is, this open-ended, creative process of becoming, can we actually steer it? Can we guide it towards good outcomes? Or is true emergent creativity always going to be fundamentally unpredictable and maybe even a little bit out of our control? Definitely something to chew on. Thanks for watching.